Okay, we're continuing on with number 5. And number 5 says that a box is filled with 30 red and 70 white balls. You randomly draw out a ball 4 times and replace it each time. Drawing out a red ball is considered a success. So we're going to complete this table and we're going to round it off to 4 decimal places. So in order to do this table, we have to remember our formula. So we have R is our trials, and then we have a formula for theoretical probability. If you don't remember that formula, I'll go ahead and write that down right now. So the formula for this is NCR. So this is total and how many you're choosing out of this table. And then you have your success, which is P raised to the R power, and then Q raised to the N minus R, which is your failure. So we're going to go ahead and do the scenarios with the 0, 1, 2, 3, and 4. We'll keep in mind that this is talking about how many red balls are going to be picked out of this box. All right, so let's start off with the first one. So our theoretical probability, there's a total of 4 times that we are actually taking this ball out, and we're going to choose 0 of these being red balls. Okay, the number of red balls out of this is going to be just 0. Our success is the fact that there are a total of 30 red balls out of the total of 100. So keep in mind that the total number of red balls, which is the success, is going to be 30 out of 100, or if you want to, you can write it as 0.3. The failure is the fact that you're getting the white balls. That's Q, and that's 70 out of 100, or you can say 0.7. So I'm going to go ahead and go 0.3, and this is going to be raised to the 0 power. We have 0 red balls. And then 0.7 are how many white balls you have. Well, if you did a total of 4 times that you are drawing the ball and you have 0 red, that means all 4 are going to be white. 4 minus the 0. And then plug that into the calculator. So if you don't remember how to get there, you're basically going to hit the math button. Let me scoot this up here. So math is way down here. We're going to arrow over to probability, and then you're going to hit the number 3, and it's 4C0, and then you're going to do 0.3 raised to the 0 power, and then we have 0.7, and that's going to be raised to the 4th power, and that gets you approximately 0.2401, and it does want us to round to the nearest 4 decimal places, so we're going to actually leave that as the number we're going to use. So it's 0.2401. All right, so to get the next value, we still are going to pull 4 balls out of this box, but we're choosing only 1 red ball to show up. So that's 0.3 raised to the 1st power, 1 red ball. 0.7 is your white, and 4 minus 1, that would be 3. So out of the choosing here, we're going to have 1 red ball, and 3 are, the rest of them are going to be white. So I'm going to go ahead and put that in the calculator. You can re-put this in. I'm just going to go ahead, and change this to be a 3, change this to be a 1, and then change this to be a 1. And that's going to get 0.4116. And then likewise, we're going to do the same thing for 2. So we have 0.3 squared, 0.7, and 4 minus 2 is 2. So we're going to have basically 2 red and 2 white. So again, I'm going to use my graphing calculator, plug in the 2's. And we get 0.2646. And then we're going to say that there's 3 red balls, so 0.3 to the third times 0.7 to the 4 minus 3, which is 1. I'm going to put that in. So this is going to be 1. This is going to be
Takara
3.
Hardwick,
And this is
to the reception desk. Takara Hardwick to the reception desk.
0.0756. And then the last one is we're choosing that all 4 are going to be red. So it's to the 4th power, which means we are not going to have any of the white. So we're going to go ahead and put this in. So we're saying that we're going to have 0 white, all 4 are red, and that's going to get us 0.0081. Okay. So that is all part A, which is, I should put part A there, that is filling this table out. Part B is drawing a histogram to show this distribution. So for part B, we're going to make a little chart here. So I'm going to go ahead and make this L shape. Basically, this is your successes, which we're going to have numbers 1 through 4. This is your R, the number of red balls. So we have 0, 1, 2, 3, and 4. And this side right here will be our probability. And looking at our chart, it goes pretty much 0, and the largest value here is a 0.26. So now I can go up to, oh yeah, sorry, the largest is 0.4. So I'll go up to, say 0.5. So I'll say this is 0.1, 0.2, 0.3, 0.4, and we'll go with 0.5 up here. Okay. All right, let's go ahead and put in our histogram. And a histogram is basically a bar graph, right? So if 0, we're at basically 0.24. So 0.24 looks like it's about right here. So pick that 0. And so next we're going to go ahead and put 1 at 4.1. So it's just a little bit taller. All right, and then at 2, we're at 0.26, so 0.26 is right here. And then for 3, we're at basically 0.7, so that's much lower down here. And then at 4, we're at 0.008, so that's hardly anything, and I'll just kind of put in a line down here. How about that? Okay, so that's our histogram. Part C is asking us to describe the shape of this data distribution. I'm going to go ahead and put C over here so you can kind of see what's going on. Well, it does not look normal. It's actually pretty high up in this region, and it kind of tailors off here. So I'm going to have to say this looks pretty skewed, and the tail end is on the right side. So I'm going to say skewed right. All right, and then part D is finding the theoretical probability of choosing a red ball 2 or more times. So if I want the probability of 2 or more, that means that the values have to be greater than, and can it equal if it's 2 or more? Yes, it could equal 2 or be more than that. So we're looking at the probability of this being x equals 2. It could be a probability where the x equals 3, or it could be the probability when x equals 4. Okay. All right, and then what we're going to do is we're going to take the probabilities that are in our table here and add them up. So the probability at 2 is 0.2646. The probability of 3 is 0.0756. And the probability at 4 is 0.0081. All right, let's go ahead and add that up here. So we have 0.2646, 0.0756, and 0.0081. And this is going to get us a total of 0.3483. And that's the theoretical probability of choosing 2 or more red balls at a time. All right, let's take a look at E. E is asking us to find, let me see if I can get this to fit on the screen. I could probably write this a little bit higher. Okay, I'll move it up afterwards. So what's the theoretical probability of choosing a red ball at least 3 times? So the probability of choosing a red ball at least 3. So at least 3, does that mean greater or does that mean less? And that would have to be looking at it being values that are 3 or more. You have to be at least 3 feet tall to ride the ride. So that means 3 or more. So X has to be 3 or more. So we're going greater again. That means we're going to take the probability of when X equals 3 and add that to the probability when X equals 4. All right, so we're going to add probability at 3 is 0.0756 and 0.0081. So let's add those together. 0.0756, 0.0081, and that gets us a total of 0.0837. Okay, let's go ahead and take a look at number 6. I'm going to have to read this first and then slide this up. Steele Canyon surveys a random sample of students out of a total of approximately 2,500 students to see if they are interested in attending a sporting event, and if so, what type of sporting event and how many friends they would take with them if they went. Of the 25 students surveyed, 10 indicated an interest in attending sporting events. The table lists the data for the 10 people, and we're going to round our answers to 2 decimal places. So these are the results of the survey for the 10 people that said they did go, keeping in mind that 25 people were surveyed, but there's only 10 people who said that they would attend or are interested in attending a sporting event. All right, let's go ahead and do part A. So part A says, what is the proportion of students who want to attend a sporting event with 3 or more friends? So we're looking at the values that the students who want to attend a sporting event is with 3 or more friends. So first of all, let's go ahead and take a look at what these values include. Okay, what is the proportion of students who want to attend a sporting event with 3 or more friends? So here's are all the sporting events, and we want to find out how many are 3 or more friends that they took with them to a sporting event. So there's 1, that's 3 or more. That makes 2, 3, 4, 5. So there's a total of 5 students who want to attend a sporting event with 3 or more friends. Out of how many? It's not out of 10. These are just the people who want to go to a sporting event. But we want to say it out of 25 because there are 25 people that were surveyed. And that gets us a total of 0.2. And part B asks us to find the mean number of friends a student would take to a football game. So we're going to look at just football games and find the mean number of friends taken there. So let's look at the football. So there's 3 friends, 0, then we have 5, and 3. So that happened 4 times in the chart. So that's going to be 11 out of 4, or let's get the decimal value. So 11 divided by 4, so 11 divided by 4 gets us about 2.75. Okay, and then part C says, predict how many students at Steele Canyon would attend a baseball game with at least one friend. Okay, so first of all, we're going to have to find out how many people actually wanted to attend the sporting event. So out of the 25 people surveyed, how many people actually wanted to attend a sporting event? And out of those ones, how many people wanted to attend a baseball game? So let's start off with the general part first. So we're looking at a total of 10 people just wanted to go to a sporting event out of the 25 people surveyed. So that's going to be 0.4 or 40%. And that represents the number of people who want to attend a sporting event. Want to attend a sporting event. So now of those, we want to find out how many actually would like to attend baseball. So how many total people had baseball as their choice? So we have 1, 2, and both of them had at least 2 or more friends. So it's both of them. So we're talking about 2 out of the 10 that wanted to go to a sporting event. So that's going to get you a total of 0.2 that actually want to attend a baseball game. Okay, so now we're going to generalize this to the whole school. So we're going to start off with the fact that there's 2,500 students, and we're going to say, well, what is 40% or 0.4 of those? So 2,500 times 0.4 gets us 1,000. So about 1,000 of the students are going to want to attend a sporting event. But out of those 1,000 that want to attend a sporting event, we're saying that 20% of them want to attend a baseball game. So we're going to multiply this by 0.2. So that gives us 200 that want to attend a baseball game. All right, let's take a look at number 7. So number 7 is looking at the scores of a recent district-wide math test, and it's normally distributed, so we can use our normal curve, or we can use a z-score, or we can use the calculator normal CDF. But I think this is a little specific here. We can see it here. It has a mean, so I'm going to go ahead and write this down. Our mean value is 82 and a standard deviation of 5. Use the standard normal table, your z-score, to answer the following to the nearest tenth. So, part A. Our first step is to find out what is that z-score. And so if you don't remember the formula, it's basically taking your value and you're going to subtract that from your mean, and you're going to divide that by your standard deviation. All right, we're going to go ahead and take this and plug in 90, subtract the mean, 82, and we're going to divide that whole thing by 5. All right, so let's go ahead and do that here. So we have a, let's go ahead and clear this out. So we have 90 minus 82, and we're going to divide this all by 5. And we got a total of this. I'm going to go ahead and change that into a decimal. So we have 1.6. So this is the z-score, 1.6. That's not the probability. That's the value that we're going to use to look at our chart. All right, and then for part B, we have to find the percent. Now remember that when you are given a z-score, it's going to give you the value from the left up until that point. So I'm going to just draw a picture so you can get a visual of what it is we're finding. Keep in mind that the mean should be right in the middle, which is 82. And we're looking at the percent of students that scored at least 90. So 90 is going to be higher than 82. But which way should we shade if we're saying at least 90? So at least 90 means it should be above this number. So keep in mind the value that's in the table is the part to the left. So in order to get the part to the right, we're going to have to do 1 minus that probability so we can get the right side of this shaded section. All right, so give me a second. I have to find that chart. Okay, I found the chart. So now we're going to look at what the value is at 1.6. So here's 1. Remember that the beginning part of the decimal is going to be here, and after the decimal you find here. So we have 0.9452. 0.9452. And so in order to find this value, we're going to have to do 1 minus the 0.9452, which gets you a 0.0548. And this wants the percent, so let's go ahead and change that to a percent. So that percent should be 5.48, or I believe that the answer is to the nearest tenth here. So I'm going to go ahead and change that. I didn't read that part, sorry. It's right here. Answer to the nearest tenth. So I'm going to change that 0.48 to be a 0.5. 0.5. Okay, so it's a 5.5 because we're rounding to the nearest 10. All right, and then we'll do one more video for the last part of this review.